Welcome to New Focused Approach to Mathematics Basic 9. This is the revised edition, and in this video we are continuing the series of vectors. In our previous video we saw paravectors. Today we want to look at perpendicular vectors. This lesson can be found in page 162. Now, before we consider perpendicular vectors, let's understand the concept of rotation of a point xy through 90 degrees. When you rotate a point through 90 degrees, and let's assume that the point is xy, or want to look at it this way in a vector form like xy. When we rotate 90 degrees, either clockwise or anti-clockwise, if it is clockwise, it will give you this value or this point, and if it is anti-clockwise, it will give you that point. What it means is that if you rotate a number xy 90 degrees, either you get it this way or that way, whether clockwise or anti-clockwise. So if I have 3, 4, and I rotate it through 90 degrees clockwise, it will be 4, then -3. And if I rotate this same point 3, 4 in anti-clockwise 90 degrees, I will get 4, that's -4, 3. Okay, that makes sense, right? And this is what I'm trying to explain to you. When you draw a Cartesian plane, which of course you've heard of this from basic 7 and basic 8, we know that Cartesian plane or coordinate plane, we have y-axis here, and we have x-axis here, and we have negative y here, and a negative x here. Now, if a point is rotated clockwise 90 degrees, that means y will come to x, and then x also go to y. When y comes to x, it will come to, so the point, if it is xy, then it will become yx, because y goes to x and x goes to y, so it will interchange their position. Then y comes to, for 90 degrees, y will come to where s is, and s is positive here, so here y will remain positive. But then the s value will move to the y negative side. That means s become negative. In that case, our rotation 90 degrees clockwise, if the point is xy, we'll get the result as y negative x, and that is what we are trying to see over here. We are going to use this concept to define perpendicular vectors, right? Now, when we talk of perpendicular vectors, and I have a vector u, which is I can know the point here to be 1, 2, 3, 4, 1, 2, so to be 3, 4. Sorry, to be 4, 1, 2, 3, 4. So 4 and then 3. Okay. Now let's look at vector AC. Vector AC, I'm moving from A to C, so I have 1, 2, 3, 4. Okay, that is no, rather 1, 1, 2, 3. Okay, so 3, and then when I go down 1, 2, 3, 4, -4, I'll get a result. So you can see here that the point 4, 3, or the vector 4, 3 has become 3, -4, which means I've rotated this vector clockwise 90 degrees, and that is the result. So you can see that vector AB is really perpendicular to vector AC. Now let's use GeoGebra to explain this further. Again, you can see that the vector blue here, that is AC, is giving us vector V, which is 2, 4, and the vector AB also, which is the red one, is giving us 4, -2. So again, you can see that the 2, 4 has interchanged, the position of x and y has interchanged as 4, 2, and then s is negated. That means it has rotated 90 degrees clockwise. Now, I could also maybe change the blue this time around to this, okay, and then let me also move this one and see if I can get 90 degrees. Good, I've gotten 90 degrees here. Okay, again, now you can see that the vector v has changed to -4, 3. Now, when I rotate this -4, 3, 90 degrees, it means that the answer will come as 3, 4, 3, -4, but because x will be negated, then we are going to get 3, 4 positive. I hope it makes sense. Good. So, and again, if I consider the original one to be u, which has been rotated anti-clockwise, then the result to be the interchanging of these 3 and 4 will come as 4, 3, and then the y will be negated. So you can see that. So this is what we call perpendicular vector. So we can change it in so many directions and we'll get perpendicular vector. So let me just try and see if I can get perpendicular vector here. Yes, I've gotten it. So again, check the answer. 5, 5 has become 5, positive 5, or 5, 5 here has become negative 5, 5. Okay, let me make one of the vector to look okay, so let's this one change as this, and then we see if we can get 90 degrees. Good, got it. Again, you can see that anytime there's 90 degrees, one vector will rotate and then it will reciprocate in terms of the x and y, and one of the x and y will be negated. Okay, that is what perpendicular vector is all about. Now let's try solving this question using the concept that we've learned. Now the question is write down two vectors that are perpendicular to this. They are perpendicular to this. That means if I rotate this one either 90 degrees clockwise or 90 anti-clockwise, I will get this particular vector, or a vector that will be perpendicular to this vector. So perpendicular to this vector can either be 7, 3, so that this one become negative, or 7, 3, so this will become negative. So any of these two vectors are perpendicular to this. As simple as that. So you rotate this one, you rotate it, that is letting y goes to s and s comes down, then one of them becomes negative, depending on where the direction you did the rotation, whether clockwise or anti-clockwise. Okay, now look at this question 2. Write down two vectors that are perpendicular to negative 6, 5. Now for negative 6, 5, if you rotate it, you're going to get 5, negative 6. Okay, then either you negate the x to become like this, or you come 5, negative 6, and you negate this one to become like that. And so either we get our vector to be 5, 6 as a perpendicular vector to this one, or negative 5, negative 6 perpendicular to that vector. I'm sure this has been of great help to you. Thanks so much for watching.